Hey guys, now let's take a look at more problems on continuity. So here we have the function defined as this, and it's given to be continuous, and we have to find L and M. So at x equal to 1, let's find the left limit, right limit, and it should be equal to the function value. So LHL is equal to, we can directly substitute 1, so 1 by L. RHL is equal to L, it's a constant, so both of them have to be equal, so 1 by L is equal to L, which gives us L square is equal to 1, or L is equal to plus or minus 1. And then at root 2, let's check the continuity. At root 2, LHL is equal to L, constant, and at RHL at root 2 is equal to, substitute root 2 here, we get 2m square minus 4m by root 2 square is 2, that is equal to m square minus 2m. Both of them have to be equal, so we get m square minus 2m is equal to L. L can be plus or minus 1, so m square minus 2m is equal to 1, or m square minus 2m is equal to minus 1. Here if you check m square minus 2m, this can be written as minus 1 is equal to 0. Then if you check its determinant, discriminant, it's less than 0, which means the roots of this equation are not real. And here if we check, this becomes plus 1 is equal to 0. So when you check the roots of this equation, they are real roots, so which means L cannot be equal to plus 1, L is equal to only minus 1. And then let's solve this equation. We get m square minus m minus m plus 1 is equal to 0. So m into m minus 1 minus 1 into m minus 1 is equal to 0, or it's m minus 1 into m minus 1 is equal to 0, which means m is equal to 1. Therefore L is equal to minus 1 and m is equal to 1. In this question also, the function is given to be continuous. We have to find a and b. So first let's simplify this modulus function. We know that for whenever x is negative, sin x is negative, which means this becomes 1 minus sin x and this becomes minus sin x. So for minus pi by 6 less than x less than 0, the function becomes 1 minus sin x whole power minus a by sin x. So this is the function here, and there's no other function to be simplified. Now let's check the continuity at first 0. That's where the transition occurs. So LHL first. That is limit x tends to 0 minus 1 minus sin x power a by sin x minus a by sin x. So when we substitute 0, we see that becomes 1 minus 0 is 1, and minus a by 0 is infinity, 1 power infinity. So this can be rewritten as e power limit x tends to 0 minus 1 minus sin x minus 1 into minus a by sin x. 1 and 1 gets cancelled and sin x gets cancelled, so we get e power a constant, so e power a. RHL, in RHL we see that it's e power tan 3x by tan 4x. So limit x tends to 0 plus e power tan 3x by tan 4x. Here let's multiply and divide by 3x and 4x. That gives us limit x tends to 0 plus e power tan 3x by 3x into 3x I'll write the next part here, into 4x by tan 4x into 1 by 4x. So I multiply and divide by 3x, multiply and divide by 4x. We know that tan 3x by 3x when x tends to 0 becomes 1, so this becomes 1, and tan 4x by 4x or 4x by tan 4x is the same thing, that also becomes 1. So we are left with limit x tends to 0 plus e power 3x by 4x becomes 3 by 4, so this becomes 3 by 4. So we have e power a as left limit, e power 3 by 4 as right limit, and the function value is given to be b. So LHL equal to RHL equal to function value, so e power a is equal to b is equal to e power 3 by 4. Therefore these two, since the base is equal, power should be equal. A is equal to 3 by 4 and e power 3 by 4 is equal to b. Here we have f of x is equal to modulus of x minus 1 minus 1, and 0 is when 0 is less than x is less than 1, and it's a greatest integer function when x is greater than 1. So first let's simplify this. For 0 less than x less than 1, f of x is equal to, whenever x is less than 1, x minus 1 absolute value is 1 minus x, so it becomes modulus of 1 minus x minus 1. This becomes this gets cancelled, so modulus of minus x is x. So now we have the function f of x is equal to x and greatest integer function of x, 0 less than x less than 1 and x greater than equal to 1. So here we have to check the continuity of this function. We see that for 0 less than x less than 1, the function is x, and we know that x is continuous everywhere. But greatest integer function is not continuous at all integers. At all integer values, the greatest integer function is not continuous. So we see that this function f of x is continuous for 0 less than x less than 1. It's continuous in this interval and is not continuous at all integers greater than equal to 1. This is the answer.